Derivatives number 3 is about how to write equations of tangent lines. And what we've done up to this point is we found the slope of a tangent line. So now we're going to be taking it one step further and writing an equation. It will be very useful for you if you remember this point-slope version of a linear equation. So here's our point-slope form right here. And what you see in for your x1, y1 is just some point that's on your line, and what you have here for your m is your slope. So in order to use this, I need to know a point and I need to know a slope. So for my point, what I know is its x-coordinate is a. So for the point, it's just going to be a, comma, and then for the y-coordinate, we're just going to plug it into our function f. And for your slope, we know that slope means derivative. So your slope is just f prime, the derivative of f, and we're going to plug that value of a in to get that numerical slope. And now I just take my point and my slope and I plug them into this point-slope format. And it looks like this. So it's y minus my y-coordinate equals my slope, which is the f prime of a, and then x minus my x-coordinate. So here is what I'm going to use. When I look at this first example, the key phrase that tells me what to do is right here where it says equation of the line tangent. So to write the equation of a tangent line, I need a point and I need a slope. And all I'm starting with is an x-coordinate for that point. So I know my x is 2. To find the y-coordinate, I just take my 2 and I plug it into my f of x function. And when I do that, I get my y-coordinate is -7. And so now I have my full ordered pair is 2, -7. On to the slope. To find the slope, I need to do f prime of x. So I'm first going to do the derivative of f using the power rule. And then once I have it in its general form, I need to know what the slope is at an x value of 2. So I'm going to take that 2 and I'm going to plug it into my f prime equation. And that gives me a slope value of -3. So now with this is my point, and this is my slope, I'm going to write my equation in point-slope form. So normally you would just leave it in this format. Presenting your answer in point-slope form is exactly what you want to do. I would totally advise that. Just for the purposes of showing you what this looks like on the graph and how it matches up, I'm going to go ahead and transform my point-slope into slope-intercept form. And just solving this for y gives me y equals -3x minus 1. Let me go over here to the graph and draw that tangent line. So I'm drawing a tangent line at x equals 2. So I'm going to go on my graph and I'm going to find where x equals 2. And I'm going to draw a tangent line through that point. So you see my tangent line is drawn here in red. It hits this graph in exactly one point. So notice I don't cut through the graph. I'm intersecting in exactly one point. And the coordinates of that point are 2, -7. And you see that's what I have as my point over here, my 2, -7. When you look at this slope-intercept form, what I see is my slope is a -3. And if I look here, I can go from this point and go down 3/1. So I see the slope of my red line is -3. And it also says my y-intercept should be -1. And as I look at my graph, right there, I'm hitting the y-axis at -1. This next example has a new word in here for you, and that word is normal. And what it means to be normal, and I have off here to the side, it just means that we are going to be perpendicular to the tangent line. So let's go ahead and get our tangent line into this graph. But in example 2, what I'm trying to write an equation for is the line that goes perpendicular or normal to that tangent line. So I'm still going through this point 2, -7, but now I'm going to be going perpendicular to that red line. And that is what you see here in blue. This is my normal line. And it just makes a right angle is perpendicular to my tangent line. So in example 2, I'm trying to write the equation of this blue line. When I see it passes through that same point of 2, -7, but it has a different slope. So I just need to remember how to do a perpendicular slope. From example 1, I know my point is 2, -7. I know my slope of the tangent line, that's the red one, is -3. To do a perpendicular slope, to get the slope of the blue line, I need to do the opposite reciprocal of that -3. And that just means to switch the sign and take this 3/1 and invert it and call it 1/3. So my normal slope is going to be 1/3. So now with this is my point, my 2, -7, and this is my slope. I just use point slope and I write my equation. And now this is the equation of my blue line that is perpendicular to my tangent line. Our last example is actually the easiest of them all. You just have to be able to interpret what's going on. I'm asked to find an equation of a tangent line. So you know you need a point, you need a slope. The key to this question is recognizing this as my point and this as my slope. What I see here is the point -1 is my x and 5 is my y. And when I see an h prime, I know that's the slope. So this is the slope at -1, and my slope value is -4. And once you have that information, now you just write your equation. And point slope form, y minus my y coordinate equals my slope, and then x minus my x coordinate. And this is a beautiful way to leave your answer. If you were doing multiple choice and you didn't see this answer represented, you would manipulate it and try to get it into slope-intercept form and see if you could match up one of the given answers. So here's my slope-intercept form, and you'd want to do that only if you were forced to do it because you didn't see your answer represented as that boxed answer. So derivatives number 3 is pretty straightforward. We are just taking it one step beyond what you already know and just taking that slope and putting it into an equation, writing the full equation of the tangent line instead of just giving it slope.